Hi everyone, Mrs. Jones here. I have big news for you. There sometimes is a situation when we are not able to factor our trinomials. And what do we do? Well, fear not, I have a solution for you. If you aren't sure about what I'm saying, what I mean by that is if we think about our magic diamond and I'm plugging in -5 and +2 based on my C and B values, I cannot come up with a number, two numbers rather, that multiply to -5 and add to 2. I can't think of anything. So what do we do? Well, there's something called the quadratic formula. The quadratic formula is based upon our standard form of trinomials, which we've been looking at as we've been factoring. And what the quadratic formula allows us to do is it allows us to solve for x when we can't factor. Now, the quadratic formula you can use anytime, even when you can factor, but probably by now you're realizing that factoring is really efficient based on this crazy formula that you're looking at. Well, if you're thinking that this formula looks insane, I have a solution for you. And the solution is a little song that I like to sing to the tune of Pop Goes the Weasel. Now, if you have not heard of the song Pop Goes the Weasel, I want you to pause this song right now and go YouTube Pop Goes the Weasel nursery song. If you know what I mean, then get ready. I'm going to sing you a little song. Here we go. The quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. I apologize for my horrible singing voice, but now you know that we can actually sing the quadratic formula to the tune of a song to help us remember it. If you want to hear it again, pause the video, scroll back. But the tune I think personally is really helpful. That's a tune I learned when I was in 8th grade, and I literally still use it today when I go and solve quadratic formula problems. So let's put this formula to the test. Now, you are probably looking at this equation and you might think, wait a second, Ms. Jones. Yes, we can actually factor this. And you're right, we can. But guess what? We're going to start with a simple problem and apply it to the quadratic formula, and then we'll go from there. So the most important thing when you use the quadratic formula is you need to go identify your A, your B, and your C values. You have to do that before you start plugging things in. So step one, my A value is 1, right? There's a little invisible 1 right here. My B value is -3, and my C value is -4. I then am going to use those numbers and plug them into that fancy formula. So here we go. I apologize for my singing. The quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. So just to point out, remember it says the -b. If my b is already negative, then this became a +3. So now what we need to do is we need to simplify this. So I'm going to have 3 plus or minus -3 squared is 9. -4 times -4 is +16 all over 2. If I keep going here, I'm going to end up with 3 plus or minus 9 plus 16. This is going to give me 25. And I know the square root of 25 is 5 divided by 2. Now, I'm going to think about my two solutions here because it's plus or minus. So I can do 3 plus 5 divided by 2, which is going to give me 4. Or I can think about 3 minus 5 divided by 2, which is going to give me -1 as a solution. Now, if you really want to just double check here, because we said we could factor this one, we know we could factor this into x minus 4 and x plus 1 equals 0. And remember, based on our ZPP, I could solve this, and this is going to give me a solution of 4, and this is going to give me a solution of -1. So I just want to prove to you that, in fact, the quadratic formula over here does work. Okay, we got the same answer as factor. We're going to try another one. All right, here we go. Step 1, A equals 1, B equals 2, C equals -5. So we're going to plug it in. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Now we go simplify. We have -2 plus or minus the square root of 4 plus 20 over 2, which is then going to simplify to -2 plus or minus the square root of 24 over 2. All right, now square root of 24, okay? We're back to our simplifying of radicals. So the square root of 24, remember, we're going to think about going to prom, okay? When I do my factor tree of 24, I can think about 4 and 6 and 2 and 2. So here's my prom date. So the 2's get to go to prom and the 6 has to stay home. So when I simplify this out down here, I end up with -2 plus or minus 2 square roots of 6 divided by 2. And last but not least, we can simplify all of this. So we end up with -1 plus or minus the square root of 6 because this is divisible by 2 and this is divisible by 2. So that's our final answer here. So realize that that blue answer is pretty complicated. So the fact that we can't factor up in this green equation, it makes sense that we get a bit of a tricky solution. But the quadratic formula is super helpful. Okay, so when we have done the quadratic formula, we need our equation to look like this. Ax squared plus bx plus c equals 0. And what's happening in this situation is it doesn't look like this. I don't see this 0. So I need to rearrange. So I'm going to subtract 9p squared from both sides. So I end up with -9p squared plus 6p minus 1 equals 0. Now you might be asking yourself, why is Mrs. Jones using the variable p instead of x? I just want to expose you to different options. You're going to see different variables on different types of tests, so it's good to get used to it. All right, now we have this wonderful 0. Yay. So here we go. We are going to be at a equals -9, b equals +6, and c equals -1. So now I can plug it in. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, now let's simplify. We're at -6 plus or minus. We're going to have 36 because that's 6 squared. Now -4 times -1, -9 times -1 ends up at -36 divided by -2. Notice that 36 minus 36 is equal to 0. Well, the square root of 0 is just 0. So this whole thing ends up simplifying to be -6 divided by -2, which means my solution here is +3. All right. So here we go. We're going to keep going. All right. Now, again, we're going to identify A of 1, B of 2, C of 6. Let's plug it in. X equals -2 plus or minus the square root of b squared minus 4ac all over 2a. Now I have -2 plus or minus 4 minus 24 over 2. All right, here we go. We have -2 plus or minus the square root of -20 divided by 2. Now, hopefully those fireworks are going off in your head and you're saying, oh no, the square root of -20, I can't do that. Uh-oh. Well, do you know what this means? Our solution to this is NRS. We are not able to solve this equation. All right? So a couple things to keep in mind. Do not use the quadratic formula if A equals 0, B equals 0, or C equals 0. If any of this is true, if A, B, or C equals 0, then there is a simpler, more efficient way of solving the problem. Here's what I mean. In this situation, we have a B of 0, and you know that you are able to factor that. That's difference of 2 squares. Here, I have an A of 0. This, back to 7th grade, that's a simple solving a problem. Here I have a C of 0, and this is ZPP, right? So keep that in mind as you are solving these. Be on the lookout for being efficient. Last but not least, I want you to pause the video. I want you to try these 3 problems, and then I'm going to reveal the answer. I am very happy for you to look at other ways of solving this. Can you factor? Can you split the middle term, or do you have to use the quadratic formula? Be efficient. All right, you're back. Hopefully you got 5 and or -4 for the first one, NRS for the second one, and 1/2 or -2/3 for the third one. Hopefully this was helpful. Again, keep singing that song. I'll post a couple other videos to help you remember Pop Goes the Weasel as well as the Quadratic Formula song to the tune of Pop Goes the Weasel. And let me know if you have any questions.